Hello, young people. Welcome to the first edition of the atomic structure. This is Origins of Atoms and Energy Unit. We're going to be talking about atomic structure here and what makes up atoms. So, first of all, you kind of already knew this. Subatomic particles make up atoms, and the subatomic particles are as follows. We have electrons, protons, and neutrons. And you can see I've even given you the abbreviations that I use very often. Sometimes I just use P. Sometimes I used to use N for these things. You can also see that I've given you the charge. Electrons are a -1, protons are a +1, and neutrons overall are 0. And I'm going to give you a little bit of a hint. Protons and electrons together make a neutron. We'll talk a little bit more about that later. Every single one of these particles has a mass, but you can see these masses are quite small. And if you really look at the electron and you see times 10 to the -28 grams, you will notice that it takes 2,000 electrons to make the mass of one proton. 2,000. And so in reality, electrons are so small that they're considered to not have a mass. Essentially, we say that they're massless, but I don't want you to get the idea that there is no mass there. There is mass. It's just so small and negligible that it doesn't really matter very much. The other thing that we need to make sure that we understand is the location of these particles. So protons and neutrons are located in the nucleus of the atom, and electrons are located in the electron cloud. And a little bit later on, you're going to understand why we focus on what we focus on when we're talking about chemical changes and things like that. Okay, so understanding this information is really important. Atoms are composed of identical protons, neutrons, and electrons. In other words, protons are all identical, neutrons are all identical, electrons are all identical. And atoms are all composed of these things. However, atoms of one element are different from another element because of one major issue, because they contain different numbers of protons. It is the protons that define an atom as an element. I know that aluminum is there because it has 13 protons. I know it is sodium because it has 11 protons. I know it is zinc because it has 30 protons. So I understand what the identity of an element is based upon the number of protons only. So we actually define that as the atomic number Z. Z and the number of protons are always the same. This idea of Z is just the way in chemistry that we identify the atomic number. We call it the Z. So when you see it on a test, if it says a capital Z, it's talking about the atomic number. Now the next statement you're going to be a little upset about because you already are going to say, hey, I know this is true. Yes, but I want you to be aware. This is only for atoms that this is true. And I never define electrons in identifying an atom. I always define it as protons. And there's a huge reason for that. It's the protons that define it, not the number of electrons. And later on in our forays in the second semester, you're going to see that electrons are going to change and protons are not. So it's really important that we understand this. The atomic number is equal to the number of protons and only the number of protons. But in an atom, protons are equal to electrons. In an atom, because an atom is neutral, protons are equal to electrons. Most of you say, well, that's the same thing. No, it's not. Atomic number is always equal to protons no matter what kind of particle we have, but only in an atom are protons equal to electrons, okay? The atomic number Z is the number of protons. We know that. So if I know the atomic number of carbon, which is 6, I know that it has 6 protons. Phosphorus has an atomic number of 15, therefore I know it has 15 protons. Gold has an atomic number of 79, therefore it has 79 protons, okay? It's a pretty simple process. If I know the atomic number, by the way, I can look that up on the periodic table. It's always there. The atomic number is always on the periodic table. On your periodic tables, the atomic number is in the upper left-hand corner. So we always will know the number of protons in an atom. Now, some more numbers that help us describe atoms. Mass number. Mass number is never found on the periodic table. The only number other than the atomic number found on the periodic table is called the atomic mass. And we're going to deal with that a little bit later, so don't panic. But mass number has to be given to you. you have to have a way to find it. And mass number is literally equal to the protons plus the neutrons. Literally speaking, mass number, a whole number, will always be a whole number, is equal to protons plus neutrons. So if I come here and I see that I have 10 neutrons and I have the nuclide or the atom of oxygen, well, I can look up oxygen. Oxygen has 8 protons because its atomic number is 8. Therefore, the mass number of oxygen is, the number of electrons is also 8 because protons and neutrons are equal. The mass number is 18, therefore we call this oxygen 18. Okay? So we look at the next one. I don't know the name of this nuclide, but I do know that it has an atomic number of 33. So I know that it's arsenic because I can look up atomic number 33 on my periodic table. I can see it corresponds with As, and that is the symbol for arsenic. So I also know that it has 33 electrons because protons and electrons are equal in atoms. And the mass is 33 plus 42. So 3 plus 2 is 5, and 3 plus 4 is 7. So we have 75 as the mass number. So this nuclide, specifically, this one atom is known as arsenic 75. I look at the next one. I have some information. I'm given the mass number over here in the nuclide column. I don't know what the name of the element is yet, but I definitely have that. But I can figure out what the element is. It has protons of 15. That means it has an atomic number of 15. Therefore, this is phosphorus. Now, I put 31 over here as mass number first. That's okay. We kind of defined that already. So I know this is phosphorus 31, in fact. This atom is phosphorus 31. How many neutrons does it have? Well, I take 31 minus 15, and I get 15 electrons and 16 neutrons. Sorry about that. I got that out of order. So I have 16 neutrons and 15 electrons. Because the electrons and protons are the same in atoms, they have to be the same. Okay, complete symbols. We need to learn this because we need to understand how we're going to write these things. So it contains the symbol of the element, the mass number, and the atomic number, and it looks like this. There's the symbol of the element right there. The atomic number goes on the bottom as a subscript. The mass number goes on top as the superscript, and you notice it's written on the left-hand side of the symbol. So if we look at one of these, here we have bromine, 8035. So what do we know? What's the number of protons? Well, where is the atomic number? The atomic number is right here, number 35. So we have 35 protons. We have 35 protons. Hang on just a second, let me get my pen for you. Okay, we have 35 protons, so we have 35 is the number of protons. Okay, the number of neutrons. Well, remember, 80 minus 35 gives us the number of neutrons, so let's take away there and get 10, that's 5. It's 45. We have 45 neutrons. Number of electrons. Well, it's an atom. There's no charge, so there are the same number of electrons as protons. What's the atomic number? Well, this is the atomic number right there. So the atomic number is 35. What's the mass number? 80 is the mass number right there, so it's 80. So this is how we begin to describe atoms and understand more about atoms. So hopefully that has given you enough information to start the process here. Thank you.